Now we're going to look at how can we solve any polynomial equation using factoring, and we're also going to talk about difference of squares. Okay? So what techniques have we practiced so far on solving polynomials? Okay? There's been multiple techniques that we've talked about. What's the one we just did? What did we just use? Quadratic formula. Okay? So quadratic formula we can use, but again, it has to be a quadratic, meaning it's something squared. What else could we use? Ben, completing the square. What else have we talked about? Brixton, factoring, and that should be your first go-to. All right, can I factor? Can I factor by pulling out a GCF? What else have we talked about? Again, we're solving these. Ben, graphing. Okay, so these would be the key ones that we've talked about. All these are different methods to solve. All right, we practiced these specifically with quadratics, meaning a degree 2 polynomial, like something squared, is my highest exponent that I have going on. Within this factoring, we have working with GCFs, pulling out the GCF. We did a lot of work with quadratic trinomials, so the ax squared plus bx plus c. All right, we had just regular factoring. We'd make a cross. We could do some factoring by grouping, where if we had, instead of just x squared plus something, it was maybe 3x squared plus something, and we had to break apart that middle term. We also have talked about difference of squares, and we're going to talk more about that today. So difference just means subtraction. So I have two things that are squared that I'm subtracting. So these are all variations on factoring. Now, for today, we're going to start talking about polynomials with a degree 3 or higher. We spent all of chapter 4 looking at factoring quadratics, solving quadratics. But now we learned classifying new polynomials, working with these new degree polynomials, and we're going to focus on if it's a degree 3 or higher. To solve a degree 3 or higher polynomial, we can still use factoring, but now we're going to have factoring in combination with solving using square roots or the quadratic formula to find these zeros. Okay, so we're now, like I said, we're upping the difficulty one click on, okay, we have now a higher degree polynomial. We might have to use a combination of methods to actually solve. Okay, so this is that sheet that I just gave to you. We want to first, whenever we're looking to factor, look, can we factor out a GCF? Okay. Next line is working with quadratic trinomials. This is what we did here in chapter 4. Okay, we can make the cross. If we have to do our groupings, we can solve these. Perfect square trinomials. This is that completing the square stuff. Difference of squares, which we're going to talk more about today. We've touched on this before, but we're going to talk more about it today. Now, second time seeing it, it needs to start being able to absorb this and being able to use this. Factor by grouping, we're going to talk a little bit more about this tomorrow. And then sum and difference of cubes we'll talk about tomorrow as well. Okay, so really the last two we're going to focus on tomorrow, but everything above here, above those bottom two, we have done. All right, so let's actually start doing some problems. So let's just look at some GCF practice. Question says, find the real and or imaginary roots. So now any solving that we do, if it's an imaginary number, we can still solve it. Meaning if we have a square root with a negative under it, we can keep going. So 2x cubed minus 5x squared equals 3x. We want to figure out a value for x that ultimately, when we put this in standard form, equals 0. So 2x cubed minus 5x squared minus 3x will now be my polynomial in standard form. That should be your first step every time. Make sure it is in standard form, so that way you can set it equal to 0. All right, and on this one, we're going to be using GCF. Let's see if we can figure out a GCF for this one. 2, 5, and 3, there's no number that's a common factor of all three besides 1. That doesn't do us any good. But we can factor out an x. And so this would be 2x squared minus 5x minus 3, all in parentheses, equals 0 after I've factored out the x, which is my greatest common factor. Okay, from this step, again, I have two things that are being multiplied. I have this x, and then I have my bigger set of parentheses that's a quadratic. I'm trying to make it equal 0. Right away, I could say, well, if this is 0, my answer is 0. So there's one solution already. Do not overlook this, okay? Because we're going to get wrapped up doing a lot more work on factoring the quadratic, and it's easy to forget about this first one that actually is a solution as well, okay? So that x hanging out there, that is still important because x can be 0, and it makes my entire polynomial equal to 0 when I multiply through. All right, 2x squared minus 5x minus 3. Okay, let's look to see if that is factorable. Remember, in the top of my cross is a times c, so this would be a -6 that adds up to be a -5. So two numbers I can multiply to get -6, but add up to be -5. -6, +1. All right, so going back to my problem here, I have x times 2x squared. This -5x is being split up into a -6x plus 1x minus 3 equals 0. I have to do that splitting because I have 2x squared. It's not simply x squared. There's the coefficient of 2. From here, I'll do my groupings. Factor out a greatest common factor from that. So 2x squared minus 6x, I could factor out 2x, x minus 3. This one also has to be x minus 3. It already is, so really all I had to factor out was a 1. So I have x times this big set of parentheses equals 0. Putting it all together, 2x plus 1, x minus 3 equals 0. So I did my factoring of a degree 3 polynomial, a cubic, simply by factoring out a GCF. It left me with a quadratic, and then I can solve my quadratic. I can continue to factor my quadratic. So again, from here, I know x equaling 0 is a solution. From this one, I could say x equaling 3 is a solution. What about this one? 2x plus 1. What would x be in this? -1/2, because remember, 2x plus 1, I want to make that be 0. So if I subtract 1, I have 2x equals -1. Divide by 2, divide by 2, x is a -1/2. So x is a -1/2 to make that set of parentheses equal to 0. So my final answer is going to be x is 0, x is -1/2, and x is a +3. Let's do another one. 3x to the 4th plus 12x squared equals 6x cubed. So my first step, let's write this in standard form. 3x to the 4th minus 6x cubed plus 12x squared equals 0. What would be my GCF now of this polynomial here in standard form? Look at the numbers first. What's the biggest number? All right, what's the biggest number I could factor out? 3. How many x's can I factor out? 2. So 3x squared is my greatest common factor. So now 3x squared times x squared is 3x to the 4th minus 2x plus 4 equals 0. All right. X squared minus 2x plus 4. Are there two numbers I can multiply to get 4 but add up to be a negative 2? I could have 4 and 1. I could have negative 2, negative 2. I could have positive 2, positive 2. Nope. This one's not factorable. Okay? Since it's not factorable, I have to go to another option. I would go to the quadratic formula because that works every time. Okay, factoring, try factoring first because that's the quickest. If it doesn't work, go right to quadratic formula. So in this one, to be a negative b, my b is negative 2, so it'd be a positive 2, plus or minus negative 2 squared minus 4 times a times c all over 2 times 1. My discriminant piece under my radical, negative 2 squared is 4. 4 minus 4 times 4. 4 times 4 is 16. So 4 minus 16 would be a negative 12 as my discriminant. All over 2. And this is what x equals. Square root of negative 12. How can I write that in simplest form? There's a negative, so I know I can bring an I out. Can I write 12 as a product of two numbers with one being a perfect square? 4 and 3. So 4 times 3. So this is I times 2 times square root of 3. So 2I root 3 would be negative square root of negative 12. So going back into my problem here, x is going to be 2 plus or minus 2I root 3 all over 2. Can do my heart surgery on this to simplify. So I'm going to have x equals 2 divided by 2 is 1, plus or minus 2I divided by 2 is 1 again. So it's plus or minus I root 3. Now be careful here, because that's the solution to what I have here in the parentheses. This is not my final answer. Because I know also this, I could have x equaling 0. So I'm saying do not forget about that GCF that you factored out. So final answer on this, I'm going to have x equals 0 and 1 plus or minus I root 3. This will be the final answer. Makes sense. See how we've upped the difficulty though a little bit on these? So you got to make sure that you're solid on your factoring to be able to work through, because simply being able to do the quadratic formula is not enough. Just being able to do the GCF is not enough. Okay? You have to use it in combination to be able to work through the entire problem. Okay? Let's do something new, something you haven't seen before. Quartic forms of a quadratic. So this is getting into vocabulary, making sure we understand. What's quartic mean again? Ben? What? Degree 4. So this means we're going to have a degree 4 polynomial that we can write as a quadratic. Okay? So if I had this, x to the 4th minus 2x squared minus 8 equals 0. And I want to solve this. I'm trying to figure out, okay, what values will get me 0 as an output. I am going to introduce, I'm going to let my variable a be the same as x squared. Okay, so I'm introducing this in the problem. This was not there to begin with. I'm creating a special rule essentially so I can solve this problem. And I'm going to say my special rule is I'm going to let a be x squared. Okay, so if a is x squared, I can rewrite x to the 4th because that's really a times a. Because it's x squared times x squared is the same as x to the 4th. So I can rewrite this, well, a times a is the same thing as a squared. So x to the 4th is the same thing as a squared when my a is x squared. So take a second to let that sink in. Okay, that's something new that we have never done before. I'm introducing a new variable that I'm calling a, and I'm saying a is x squared. So instead of writing x to the 4th, I can write a squared. So it would be x squared times x squared is my a. Twice, it'll be a squared. So a squared minus 2 times x squared, well, it's not x squared, we're going to still call it a, minus 8 equals 0. So now I've rewritten my quartic as a quadratic. And the benefit of writing this now as a quadratic is we've had all kinds of practice solving quadratics. A squared minus 2a minus 8. So if I have two numbers, they'll multiply to get negative 8, that to be a negative 2. I have negative 4, and I could have positive 2. So now I have a minus 4 times a plus 2 equals 0. I factored that a squared minus 2a minus 8 to be a minus 4 and a plus 2. Now let's put x squared back in. Using this a substitution is just making a simpler problem than I can factor. So now it's really x squared minus 4 times x squared plus 2. So using that a substitution gets it to a form that's just a quadratic that I can solve, or that I can factor. Once I've factored that quadratic, now I'm going to put x squared back in. So this is factored form. X to the 4th minus 2x squared minus 8 is x squared minus 4 times x squared plus 2. I want this to equal 0, so I have to look at each one. So if I have x squared minus 4 equals 0, that means x squared equals 4. So x is going to be what? Keep going. 2 and, not 2 and 1. Nope, there's no I or anything going on in this one. So what can I square to get 4? 2 and 2 and negative 2. Okay, if I'm undoing a squaring, I have to bring in that plus minus. Okay, so x squared equaling 4, 2 squared is 4, negative 2 squared is also 4. And then also I have x squared plus 2 equals 0. So x squared is going to be equal to a negative 2. If I undo the squaring on the x with square roots, that brings in the plus minus. So x equals plus minus square root of negative 2. Square root of -2, I don't want any negatives under my radical symbol, so that would be I root 2. So on this one, my solutions are x equals plus or minus 2, x equals plus or minus I root 2. Let me show you something else. We're going to cover this more in the upcoming weeks. Look at the original degree of my polynomial. That x to the fourth, that power of 4 tells me how many solutions I will have every single time. If it was x squared, I know I'm going to have 2 solutions. If it was x to the 10th, I know there would be 10 solutions. X to the 4th tells me I'm going to have 4 solutions. I had 2 here, the plus minus. I had 2 here. I have 4 solutions going on. I found all 4 solutions. We'll talk more about how that exponent tells us the number of solutions and what we can do with it in the upcoming weeks. But right now, it's a good checkpoint when you solve this. Make sure you have the correct number of solutions based on the degree of your polynomial. Let's do another one to practice this a substitution. X to the 4th minus 7x squared plus 6. Doing the same thing, I'm going to introduce this a, which is x squared. So now I can rewrite my polynomial as a squared minus 7a plus 6. Let's see if we can factor this. So 2 numbers multiply to get 6, add up to be a -7. -6, -1. So this becomes a minus 6, a minus 1 equals 0. But I know a is x squared, so I'm going to rewrite that using x squareds. So x squared minus 6, x squared minus 1 equals 0. I need to solve each of these. So x squared minus 6 equals 0. Tells me that x squared would be a positive 6. If I square root both of those, x would be plus minus square root of 6. The square root of 6 is not one that I can simplify. There's no negatives to pull out an I. There's not a product that's a perfect square, a factor that's a perfect square. And then x squared minus 1 equaling 0 tells me that x squared would be 1. So if I square root both sides, x would be a plus minus square root of 1. What is square root of 1? It's 1. Okay, so x would be plus or minus 1. So x is plus or minus 1, x is plus or minus 6. I have 4 solutions there. My original degree was 4, and so I found them all. So introducing that a value takes a quartic and puts it into a quadratic, which we've practiced a bunch solving quadratics. We can use that, but then at the end, after we factored, change your a back to x squared and then solve from there. All right, difference of squares. So we've talked about this, but now we're at a point where I want you to study this a little bit more, memorize this, be able to work with this, because this creates efficiencies that we can use that will help us solve the problem much faster. Because this now potentially could show up within a problem, and if we recognize it right away, it'll let us continue on with the problem. So difference of squares. Difference means subtraction. And it's saying 2 things that are squares are being subtracted. So if I had a squared minus b squared, my property tells me that this every single time is a plus b, a minus b. Okay, that's what difference of squares is. So if I had one that looked like this, 81x squared minus 9 equals 0. right? This is a difference because it's subtraction. So I'm trying to think, okay, what squared would get me 81x squared? So let's first off think of the 81. What squared gets me 81? 9. And then x squared, that would have to be an x there. So 9x squared in parentheses is the same thing as 81x squared. What can I square to get 9? 3. So this is a difference of squares. My a value I would think of as just 9x. My b value is 3. And do not take it as negative 3. The property, it has to be subtraction going on. So you don't have to look at the sign as a negative 3 or anything. It is the b value, the number is just 3. Okay, so up here, a plus b, a minus b. Well, a is 9x, so I have 9x plus 3, 9x minus 3 equals 0. I factored this. So 81x squared minus 9, I can factor that down to 9x plus 3, 9x minus 3 using difference of squares. But I'm not done. I'm still trying to solve. So if I were to solve this, I would have 9x plus 3 equals 0. So 9x equals a negative 3. X would be negative 3 over 9, which is the same as a negative 1/3. On this one, I'd have 9x minus 3 equals 0. So 9x now would be a positive 3. X would be a positive 3/9, which is the same as 1/3. So my two solutions here are positive 1/3 and a negative 1/3. And that checks out because it was a degree 2 polynomial. So I know there had to be two solutions and only two solutions. But the two solutions, one could be imaginary. In this case, they weren't. Okay, but that tells me how many solutions I'm going to have. X to the fourth minus 81 equals 0. What would my a and my b value be on this one? What would b? What squared is 81? 9. What squared is x to the fourth? X squared. Because x squared squared is x to the fourth. So now this becomes x squared plus 9, x squared minus 9 equals 0. So to solve each of these, x squared plus 9 equals 0 tells me that x squared would equal a negative 9. If I square root both sides, I'm going to have x being a plus minus square root of negative 9, which is plus minus I root 9, which is plus minus 3i. And on this one, x squared minus 9 equaling 0 tells me that x squared has to be 9. Square root both sides brings in that plus minus. So x is a plus minus 3, and x is a plus minus 3i. I initially had it raised to the fourth power. Oh, it's not working for me. So if it was raised to the fourth power, it tells me I had to have 4 solutions going on. Okay. All right, let's get started on, I had just a couple duplicate problems. Let's get started on the assignment. So the assignment for tomorrow, several that you have to find the solution. So first set says find the real or imaginary solutions of each equation by factoring. And the second one says actually to solve. So it could be using factoring with GCF, using that a substitution, using a difference of squares.